Dr. Seedman, thank you for coming on Movement Fix podcast.
My pleasure. Thanks for having me.
Absolutely. I am very interested to speak with you because I think that there are some things that we disagree on, especially I think around squatting. And I'm really curious to talk about that, not in an argumentative way, but I really want to hear why you have the opinions that you have about certain things. Because, you know, we all have different backgrounds. You have a PhD in kinesiology?
Yes, that's
Is that
correct.
right?
And kinesiology, it was kind of like neuromuscular physiology / motor learning.
Mm-hmm. Right. And I'm actually quite curious. I'd love to hear what is the coursework like in getting a PhD in kinesiology? What does that look like?
Yeah, it's pretty much like more of the same of what you would have undergrad and master's. Is just higher level classes. So, if it was exercise physiology undergrad, it's like, okay, you got the more advanced exercise physiology, applied exercise, and, sports performance. And then basically you take it a step further, just examine all the literature, discussing with your professors, with your different fellow doctoral classmates, and so it's not too much different. You just basically get a little bit deeper into things. Got to do a little bit more investigation yourself. The amount of work required from you ends up being quite a bit more, and then you have to take a lot more statistics than you'd like.
How much statistics is more than you would like?
Oh man, I think I've taken at least a total now of like 8 statistics classes between undergrad, masters, and PhD. But PhD was like 4 statistics classes. And I understand that, it's looking at research. You got to be able to kind of look at the flaws with it, because not all research has been done properly, or I shouldn't say properly, but there's oftentimes weaknesses in some of the calculations and some of the way they did the statistics. So it's good to understand that, because when you see maybe, and this, I think we can talk about this, when you see data that maybe doesn't line up with like foundational elements of science, it kind of makes you scratch your head and be like, how did they perform that study? How do they run the analysis, and how do they run the different types of statistics? So it's interesting.
Yeah, it's like research is not as clear as people like to make it seem, right? Like we pick a study, oh, it shows this. Well, there's probably a lot of other studies that show the opposite. And how do they even do it? Like people don't even necessarily read how. So that's why the statistics is so important, right? Because publishing research, you need to understand that. Reading research, interpreting research. I just started actually reading a kinesiology textbook, because I realized that in my doctoral program of chiropractic, we didn't really take a formal kinesiology class. And so I was trying to understand, like, how does a kinesiologist think? Because it's quite different. Which kind of leads me into wanting to talk about squatting and squat stance and form.
Right.
And I've read a few of the articles on your site, and I think that what I took away was that the actual setup that you recommend for the degree of toe out and like the foot position and the depth is really the thing that varies from, I guess you could quote unquote, mainstream strength and conditioning.
Right.
And you noted about the importance of 90-degree angles at the knee joint and the torso to the hip. Am I?
Yes.
Okay. I would love to hear why. And I say this with no hostility.
No. I can tell. First off, we've been in communication for a few years now, just back and forth, just lightly. So I always appreciate the way you're, very civil about whatever we discuss. So I can tell right now that that's not your approach in terms of trying to, make this a hostile argument. I think a lot of people do try to do that. They choose, their stance, and I got to be careful of that too, because it really is like, oh, I'm not going to, change no matter what. I don't care what this person says. It's like, no, here's what I'm going to think, and don't tell me otherwise. So I think with kind of what you're doing and your approach is like, hey, I want to hear the other sides. I want to look at all the research. I want to look at what other people are doing. Even though I may have my own beliefs, it's always good to kind of get educated on the other side. So I think, like you said, there's a lot of conflicting data on the topic of squats, but that's really for any topic in kinesiology, or really any science for that matter. There's always going to be sides to the argument for anything, whether we're looking at, ketosis diet, or whether we're looking at intermittent fasting. There's so many different studies where one side of things will be, oh, this is awesome, this is the ultimate for health and performance. The other side says, no, this can actually be detrimental on performance. So so I'm the first to admit there is plenty of research suggesting that going full depth or going deep is great, okay, or it's acceptable, okay. But then there is definitely certain areas of research that would say, hey, 90 degrees or roughly, if you want to call it parallel or 90-degree joint angles, and we can get into more about how I kind of what I use as far as the guidelines for that. But there's plenty of research to back up that as well. So at some point you kind of have to say, okay, if there's research to support both, you have to look at, okay, what is just the foundational elements of exercise physiology, of biomechanics, of neuromuscular physiology, just the things that we've kind of known for maybe the last 20, 30 years about the basic elements of the science. Like almost forget, like, okay, let's almost like try to, I don't know, eliminate the whole, like what other coaches have done, what we've done in the past, what we know to be kind of common sense, because sometimes those common sense things that we just take for granted, it's just been embedded in our minds from what we've done. But when we look at the science, of length tension relationship, okay, of muscle fibers and how they function. Muscles, they don't function great when they're overly stretched, as you know. They don't function great when they're overly shortened, okay? They kind of have this optimal range, and it's not a crazy short range or small range, but it's not quite as big as what a lot of people would suggest. So I pretty much, have tried to follow that, knowing that, okay, muscles kind of operate in this optimal range, and it tends to be kind of this 0 to 90 degrees, so to speak, because when we look at biomechanics at that point, okay, so kind of take away the structural muscle physiology. When we look at biomechanics, we look at things dealing with lever arms and anatomical levers. Mm-hmm. We know that 90 degrees tends to produce the most force, the most power. Basically, we have the best leverage. It's the most biomechanically efficient positions, okay? Now, you can also say, well, there's the most shear and compressive forces going on there too, okay? But that's where you kind of have to look at the human body, at least in my standpoint, as a human body, not as a robot, okay? Because if we look at it as just like this robotic segment of forces coming in, it's like, oh yeah, the force is coming in to the joints at 90 degrees. It is high. But then we have to say, okay, but are the muscles in a good position to be able to absorb force? They are. They're in an incredibly strong position. So it's like that shear and compressive forces argument, it's not the most...
it's misleading, right?
Misleading.
Because the muscles will essentially make it so that the passive constraint of the joint doesn't have to withstand the force, right?
Exactly.
Yeah.
Exactly. Because if we use that argument of the shear and compressive forces and relied on that solely, we would say that movements such as like Romanian deadlift would be crazy, horrible for the low back, okay, because of the forces coming into the spine. But we know that if you set the spine and lock it in properly with the local musculature, yes, there's a lot of force coming into the spine, but it's also the best way to strengthen the muscles around the spine. So it's I had a biomechanics professor when I was at Indiana University, several of them, so I don't want to say which one this was, but I remember we had a class and he was talking about RDLs, okay, and he was an old school biomechanist, okay, and he literally told the class, he's like, the research now is saying that movements like RDLs are not bad on the low back. He's like, I just don't understand that though, because that doesn't make any sense to me as a biomechanist. And I'm thinking like, that's interesting, because he was relying on this kind of old, shear and compressive forces, looking at the human body as this robotic kind of machine that doesn't take into account muscle physiology. So to me, that's where you have to look at all the sciences. You can't look at just biomechanics. You can't look at just the structural physiology. You have to look at, everything and combine it, and they have to match up. They can't contradict each other, because as we know, usually for the human body, kind of everything works together and everything impacts everything else. And, there's elements of neuromuscular physiology. And this is one of the things that I studied a lot with proprioception and muscle spindles. Okay. So muscle spindles, as you know, those are kind of those little feedback mechanisms that are kind of embedded within our muscles. They give us all that kinesthetic awareness. Proprioceptive feedback basically gives us that sense of feel. Those are optimized when the muscle is stretched, but they have to be stretched within a range, because if you overstretch a muscle, okay, they actually don't give us as much feedback, because to gain more range of motion at some point, we have to sacrifice muscle stiffness. Okay, it's just kind of how the rules of muscle physiology are.
Like the muscle tone, like the amount of contraction has to relax for the muscle to actually lengthen to the point that people are trying to get to.
Exactly. So it's like, maximal muscle stiffness would be like, okay, the muscle didn't even move. Okay, so then you have no locomotion. You need some relaxation of that. You have to have a degree of stiffness, right? So like you said, it's kind of the amount of tension or taut, how taut a muscle is. So if we look at that, muscle spindles, they give us maximal feedback when the muscle is stretched, but also when the muscle is under the most stiff conditions under the stretched scenario. So it's kind of what ends up happening is like, okay, I go to 90 degrees. Now I can get further and I can get more stretch, but I'm also sacrificing a pretty high level of muscle stiffness. So we start to lose a little bit of feedback from some of our proprioceptive elements at that point. There's actually some research to show that, that basically when we fatigue, oftentimes our range of motion becomes greater. It doesn't become shorter. And a lot of people think, oh, as you fatigue, you're going to start shortchanging the range of motion. That's actually, a lot of the research shows we actually start using larger range of motion because we lose a lot of that stiffness.
Yeah, it makes a lot of sense. Like I think that there's a real balance here of joint health and stressing joints at like the end range versus muscles contracting to prevent the end range loading, especially under high loads or velocity.
Right.
When you could be stressing, like let's say the end of hip flexion or the knee in a certain way. I mean,
right.
Is that kind of why the 90-degree angle at the hip and the knee for the squatting is so that you can generate maximal force using, the loads that allow you to do that without taking the muscle to a length where you're losing that muscle spindle feedback?
I think that's actually a very sound.
That's kind of because I was thinking about this a lot, right? Because I've thought, as I'm sure you have, I've thought a ton about squatting and like seeing it from fresh eyes, like you said, right? Because you could read a book and you learn something in school and you don't think for yourself ever.
Right.
And if you get taught by a professor who teaches old school ways, then you're going to think old school unless you can look at it from a different angle. And I was thinking, like, we know that and you've written about this a ton, like we know that there's differences in lever lengths. And we know that you can't break the laws of physics. Like if somebody has longer legs or shorter legs, it's going to change how the body has to move.
Right.
And we know that there is variation in hip architecture. And I was thinking, why do people disagree about the stance? And I realized that there's a fundamental difference in squatting, right? Like I think about squatting for people because I did like so much CrossFit for, almost 10 years. And there's a lot of Olympic lifting. So I think there's an argument to be made that for people who are trying to squat into the maximal depth they can, which is not what you're suggesting, right? You're doing it for a different reason. And I think that's important to understand. If somebody's trying to be an Olympic lifter and they need maximal depth, they can only really change their stance or the amount of flexion in their lumbar spine to maximize their ability to flex the hip joint and maybe tilt the pelvis to get their center of mass even lower, which is a totally different way than you're approaching it, which is thinking about the stress at the different joints and the muscle spindles and the length tension relationship in order to train with like those things in mind. Am I getting that?
You nailed it probably better than I can say it. that was exactly it. I mean, and this is, it goes a little bit unnoticed in some of my writings. I probably need to emphasize it more, but I do try to explain and express that what I'm advocating is not for the sport of Olympic weightlifting.
I did read that in your article. You did say that, like, for a certain group of people, it doesn't apply to the Olympic lifters. The problem is so many people are doing Olympic lifting who aren't built or have the need to push their bodies in positions that may lend itself well to the sport of Olympic lifting, but maybe not to the longevity of the body. I mean, that would be, however, I'm sure there would be an argument against that, that how can we prove that that has negative, effect on the long-term health of like the hip joint and the lower back?
Right. No, it's a great question. No, I think that's the main thing too, is I think kind of looking at what am I applying this towards, and what am I kind of recommending this type of squat for? It's, I work with a lot of athletes, a lot of general populations too. I don't really work with many Olympic lifters. I used to a little bit when I was back at Indiana University, just some casual stuff. I did a little bit of competing myself, but at the very low level, and worked with a few people for competitions at very low level. So I'm by no means an expert Olympic weightlifter. I don't want anyone to misconstrue that. But now when I'm using the squat, or using any movement for that matter, it's kind of like, hey, how can I optimize muscle function for the purpose of athletic performance? Okay. How can I get it to transfer to the field optimally? Okay. Which is kind of back to motor learning and motor development.
And the field meaning the sport field that the person.
Yes.
Okay.
Exactly. How can I get transferred to the competitive circumstance optimally, or even their practice scenarios best? And then, what's going to be the most therapeutic on their joints, on their connective tissue? What's going to help, maximize their whole kind of injury prevention standpoint? And then even from a standpoint of, optimizing strength, optimizing hypertrophy, because as you know, a lot of these things kind of play hand in hand. Even though I don't necessarily train, exclusively bodybuilders, I do have a few bodybuilding clients, but even they are pretty into like muscle function and optimizing, health of their body. So the 90-degree thing to me, it's like, okay, this is the optimal method for what I just discussed there. It's kind of like, okay, we're talking about getting it to have the best transfer to athletic performance, having the most therapeutic effect on the body where there's the least potential consequences or risks. And then even if you look at it, a lot of people will argue from hypertrophy standpoint, but my argument for that is that it actually maximizes strength and hypertrophy, because again, when we lose some of that muscle stiffness, like we talked about, the way you lose muscle stiffness when you go too deep is you're actually sacrificing recruitment at that point. It's like, how do I get deeper? It's like, okay. And this is, some people have trouble with this because, it's a little weird. And when I coach up a client and show them how to do a squat and, everything's straight, you can see it in their body, and they'll even tell me, it's like, oh man, at 90 degrees, it felt like everything was like so engaged. Everything was so tight. And I'll sometimes say, okay, now just go a little deeper for me. And I'll have them come back up and I'll be like, okay, what did you feel? And immediately they say, wow, okay, to get deeper, I had to like let go of a lot of tension. Okay. So oftentimes that extra depth, it's like, is that more activation? Is that more muscle recruitment, or is it actually less? And EMG is not, it's not always the best way to determine that. And there's really no, unfortunately, it's the only way that we have kind of currently, but it can be a little bit misleading, and we can get into that too.
I'd be curious to hear why it can be misleading.
Yeah. So it, we can talk about that. That's a tricky one, because this is a little bit more, anecdotal. It's not like I can't prove the whole EMG thing, but I've seen some things with EMG where sometimes a high reading is not always the best. And for example, like the guillotine press, which is a chest press where you go to your neck. And actually Brett Contreras did a study on this. I think a few other people have looked
like
at
a
this.
Bench press, but you're just way up here.
Yeah. Okay. Bench press to the neck, which we know that's not actually like optimal for the pectorals in terms of like, optimizing their function, because the pectorals tend to get activated best when the shoulder is in, depression. Okay. So, but for whatever reason on EMG, it shows up that the guillotine press produces the most muscle activation. So it's like, that's odd. Okay. And we also know it's biomechanically and even like, from a standpoint of like, joints and osteokinematics, it's not the best position on the shoulders.
Maybe that's why the muscle activates higher, because it's trying to protect the integrity of the joint. And it's like, ooh, you shouldn't be doing this.
Exactly. So it's like, okay, so we have a few trains of thought there. One is like, okay, like you just said, you put the body in this potentially hazardous position and you get these crazy EMG readings. It's like, ooh, is that good though? All right.
Right.
We can talk about that.
It's like the balance of joint health and optimal position versus muscle recruitment again, right? Like
Exactly.
just because you can recruit the most here, does that mean you're going to do it here to hypertrophy the muscle?
Exactly.
And that's kind of how you think about the squat, right?
Exactly.
That's how you're thinking about the squat.
Exactly. And then the other standpoint is kind of like, okay, is the EMG actually telling me, is it accurate? Because is it just sending like these, it's dealing with signals. It's dealing with electrical signals. It's like, okay, is there something else going on there that maybe it's just not as accurate as we think possibly? Because you would think when you're in that guillotine press, it's like, wow, that's really getting into the shoulders more than the chest. Why is there such a high reading in the pectoral muscles on that? So again, I think it's either one of the two reasons. Like you said, you're either putting it in such a potentially hazardous position. It's kind of in this survival mode where it's forced to maybe, fire more. Okay. But again, is that necessarily a good thing, especially when we talk about motor learning and how movement transfers, because now we're ingraining this horizontal pressing pattern movement into our nervous system. That's a little flawed, right? And I always tell my athletes, the way they press, okay, the way they do a chest press, that transfers into running mechanics, because it kind of changes the way their shoulders and arms are positioned when they're running. I see this all the time. The people that are,
they're like,
they're real tight in their shoulders, arms are up here. They don't know how to relax. And you watch them bench press, guess what? It looks like a guillotine press. You start changing their chest press and having it be tucked and getting in that right position that we know, and powerlifting has given us a lot of great insight into that, right? Okay.
Mm-hmm.
When they do that, it's like, wow, you start to see it change their running form. They start saying like, wow, my arms feel so much more relaxed when I run. I can drive better. So that's kind of that principle of motor learning, which is why, again, back to that 90-degree thing. It's like, all right, for the majority of the time on the playing field, when we're doing sports, we want those 90-degree angles. Those are pretty strong positions, when we're running, when we're jumping, when we're cutting. So how I train impacts how I move on the field. If I'm training with pretty extreme positions, I'm probably going to be ingraining to a degree some like difference or different like positions and joint angles that are going to transfer to the field. And I've seen this a lot too, where a lot of hamstring pulls I see with people that do large range of motion RDLs and stiff leg deadlifts. I see it so much. And it's like the more they do those movements, the greater the likelihood of pulls. Again, I don't have necessarily research to back it up. I've just seen it enough being in this field for, and training people for what is it now, about 17 years, where it's just such a common occurrence. I see it all the time.
And so, do you think that's just because they've loaded like the longest point of their hamstring, that they kind of did something to the feedback mechanism, or do you have like a theory on why that is?
No, I think it's that. I think number one, maybe they created a little bit of structural weakness in the tissue. Okay, so that would be kind of like the simple thing of looking at that, because maybe even some like very subtle like extreme micro trauma where the length tension relationship, we can go back to that. Maybe the muscles are no longer firing in that neutral length tension relationship. And actually, to be honest, now I think about the research, there is a lot of research showing that different forms of training can change the length tension relationship to make it longer, which in one sense you would say that's good, but it's like, wait a minute, are they operating under the conditions where their natural stopping point for sprinting is 90 degrees, or does it feel farther than that, or is it farther than that? And then it's like, okay, then they're overstriding every single stride that they take, and again, is that contributing to some of those hamstring pulls? So
there's just like, there's such this like underlying belief in strength training, just generally, let's say, that exercises need to, like, they're best if they're done through the full joint range of motion.
Right.
And I actually don't agree with that. I don't think, like, let's take the squat, right? Let's go back to the squat. It's sort of like somewhat of a conundrum, right? Because like, if we talk about overhead pressing, you have the natural like changing orientation of the shoulder socket, so that you can then move, the humerus on that. And some of the motion in what looks like shoulder range of motion is the repositioning of the scapula.
Right.
In the squat, there's no such thing as like an acetabular femoral rhythm that I'm aware of that anybody's ever talked about.
That's a good point.
But I mean, maybe there should be. The problem is that the pelvis is attached to the, like you have the pelvis with the hip sockets squished on the sacrum connected to the lumbar spine. So if you wanted to have a acetabulo-femoral rhythm, you would have to flex the lumbar spine, which people are, against because of potential disc herniation, disc bulge stuff. So then we do these heavy squats, which require us to lock the pelvis from moving. And then we're trying to go to the maximal hip flexion. And it's like, well, are we even as human beings supposed to do that?
That's a very interesting point.
So I actually for a long time have held the belief that I want to stop a little bit before the end range of hip flexion, because that's a sacrifice I feel like makes sense to make. I mean, maybe it's not even a sacrifice, so that I can maintain, like, prevent motion of the lumbar spine while still working through the hip range of motion. Right. And so then that would be different than doing like a body weight movement squat where you allow the lumbar spine to flex and you then get the acetabulo-femoral rhythm, let's call it. That makes a lot of sense to me. So I don't disagree with the way that you have the 90-degree. Like, I actually think there's real good logic and reasons for that. But I'm curious, if you took somebody like me, I'm quite retroverted. So like if I squat with my toes forward, I can't go very far. If I toe out, it's like, oh, that feels great.
Right.
But then it's like, maybe I'd be curious what you would say to me. Like if I came to you, should I toe out a little bit so that I can work through because I need to position the head of the femur in the socket differently so that I can clearly like rotate through the acetabulum, but maybe stop before I get down to the very bottom to keep that muscular tension, sort of like an in-between of our opinions.
Yeah. That's interesting. Yeah. Let me take one little step back here and then I'll get right back.
I saw that you had something. You had something.
The whole acetabulo-femoral rhythm thing you mentioned, that's interesting to me, and I actually think there is maybe something to that, not as extreme or as obvious as the shoulder joint, but I always one thing I haven't really written on this yet. I need to, but my opinion that if someone is going to squat ass to grass, okay, like naturally speaking, okay, to me the most natural ass to grass squat is with lumbar flexion.
Me too.
Because like if you actually look at like the third world squats, whatever you want to call it, I don't know if that's politically correct now, but whatever. The deep squat that we see in maybe Asia. I got nothing against that because it's a totally different thing. It's a resting position. That's something that I'd love to see more humans be able to get into. I think that's great. I got nothing against that. You'll rarely, if you look at images of people squatting in those positions, how often are their backs totally in this neutral or slightly lordotic position when they're doing that? It's not.
No, never. And same with the classic photo of the baby squatting.
Yeah.
They're totally flexed.
Exactly. So it's like, okay, I got nothing against ass to grass as long as it's with a little bit of natural flexion, okay? But at the same time, do we want to load a position where there's a lot of flexion or significant flexion? So that's my whole kind of like, okay, we probably don't want to load ass to grass, because if ass to grass should be done under flexion positions, and we know that loading flexion with heavy weights is not good, there's your argument there. So it's kind of like, and I feel like the counter argument to that would be, people would say, well, we have tissues that do adapt, therefore we should do it. Right. And I think that's great. That's a great argument there. My thing, I don't know if you ever had a chance to read this. One of my yoga articles that I wrote, I think it was maybe last year sometime, but I did all this investigation, just looking at some studies, and it was a combination of hardcore research, okay, and some empirical data, if you want to call that, some anecdotal stuff, some experiential stuff. So it was like a combination of things, some statements from doctors and physicians, some orthopedic surgeons, and basically what I found after looking at everything is that dancers and a lot of yoga people that end up developing some pretty extreme joint issues. And it's often the ones that are able to get into the extreme positions most easily that end up having the most extreme issues eventually, not at first. So it's like, to me, it's like, okay, just because we can do something doesn't mean it's optimal. And just because we can do something right then and there without any apparent issues doesn't mean it's not going to be causing issues later on. You always have to look at the big picture, to me.
Right. The long-term, like, there are so many things we could do. I like to make the joke that, like, I could poke myself in the eye and I would probably, like, my eyeball would callus. Like, physiologically, my body can do that. Does that mean I should try to express my ability to adapt that way? Just like, why? I don't disagree that you probably can load the lumbar spine into flexion, but is that the best way to develop strength and power to translate into, like, again, it's sort of like, what is the reason that you're doing this? Exactly. And if the reason is to strengthen every joint in every position, okay, sure. I don't see why that would be a problem. But if your goal is to train people to be strong on the field or for joint longevity, I certainly don't know of any studies or any reason to think that taking your lumbar spine into flexion while you squat is somehow better for it, as long as you're using that range of motion in normal everyday use, right? Because, like, the lumbar spine has a ton of flexion.
Oh yeah, I'm all for lumbar flexion. I mean, I do it hours. I do it for hours a day when I'm picking up weights off the ground for my clients and just, repositioning things. I'm spend a lot of time, in flexion and even though I don't train there. And so that's one of the arguments people say, oh, well, you don't go to 9 or past 9 degrees. What's going to happen when you pick something off the ground? It's like, I'm just fine. It's not like I lost that ability. It's like, as humans, we've had that ability before the fitness, the dawn of the fitness era. It's not like, to get that ability to go down to the floor and pick something up, we had to have learned how to squat ass to grass. Like, no, we've been able to do that way before the whole ass to grass training thing ever came on the scene. So for me, when I have people do 90-degree squats, we're not taking that ability away from them. We're just strengthening the muscles through a kind of this medium range of motion or natural range of motion where it can handle heavier loads pretty well.
Yeah, it goes just so, at first glance, when somebody sees that, it goes so against the idea of, like, we need to maximize joint range of motion. We need to I think maximizing joint range of motion is, you should have that, but stressing the joint with a lot of load at the very end range of motion, I think you're right that there are some long-term consequences that we need to at least consider.
I agree.
And like I see it as you have passive and active constraints of a joint, right? Like, the neuromuscular system is the active constraint of the joint. The passive constraint of the joint is either, like, my elbow flexing and my forearm runs into my bicep, or the ligaments, or the structure of the joint, like the bones running into each other. Like, I don't know. I wouldn't want to load those when I'm trying to do neuromuscular training.
Right.
So it's like different rules, different games, different rules.
Yeah, that's a good way of putting it.
And I think that we like to think there's one right answer, but it's like, well, if you're going to do this, there's different things than if you're doing this.
Exactly. Just like, like I said, Olympic weightlifting, it's like, hey, if you got Olympic weightlifting, guess what? Then I'm going to recommend, yes, you're going to have to go, ass to grass. Now, one interesting thing here, just to get a little side topic, is that you are starting to see some Olympic weightlifters use 90-degree squats in their training mixed in, which I think is actually can be pretty beneficial, because it's like, okay, maybe that's going to help just develop strength in that area, and maybe they're protecting their joints a little bit and saving some of those extreme positions for more occasional circumstances when they need them. I had I can't remember the Olympic weightlifter, Christian Thibodeau mentioned him in a podcast I had a while back. Gosh, the Olympic weightlifters, I have trouble with their names because they're always, Russian or Ukrainian
names that you're not familiar with how to pronounce.
Yeah, exactly. But anyways, he was saying that this guy is using a lot of 90-degree squats in his training, even though when competition comes, he obviously goes deep. And he didn't really explain why he's doing that, but you know, we were thinking about it. It's like, maybe it's for some of the reasons that we're discussing. So
I wonder
I
if
never answered your question though about your scenario if I was
Oh,
coaching you.
yeah. What? So let's take this as an opportunity to do that.
Yeah. Sorry, I got sidetracked there. It's like so much juicy like things. It's like you say one thing, it's like, oh, got to get there, and you say something else. Like,
Right.
no, I think you know, it's always I can tell you how I would do it. Okay, now I don't think any one particular person or strength coach in the industry would fully agree with it because everyone's got their own methods. Okay, so when somebody says, oh, well, you know, this person doesn't agree with you, it's like, well, very few strength coaches fully agree with anyone because we all have our own methods, right? If we didn't, we'd be copying each other. So this is my particular method. I would kind of go over like I usually start off people with like a single leg stand position just to kind of teach them hey, here's how it feels to grip the foot down, okay? And we can get into that more, but I'm sure you're aware of how foot and ankle activation kind of has an impact up the kinetic chain and whatnot. And I show them, okay, here's what a straight foot, straight hip, straight knee feels like, even if they have, you know, very externally rotated hips. And it sounds like that's kind of the case for you a little bit.
I'm all torsioned up.
Okay, nice. So I would show them, hey, even though this is going to feel a little unnatural right now, just try this for me. And I explain, hey, this is kind of a neutral position. If we look at this position, say from like an athletic performance standpoint, if it's running, for example, we would say that biomechanically, that's probably pretty sound. So even though it feels weird, let's try that. I have them do that a few times. And then I say, okay, now let's take this and kind of transfer this concept into a squat, okay? So I say, all right, grip down really hard with the feet and basically keep the hips and knees and feet neutral if you can. Okay, it's going to be hard for some people, and oftentimes it's going to want to kind of slide out as we go. And then I tell them keep as much full body tension as possible and keep your posture locked in. And we usually will take 5 minutes to go over posture, just that neutral alignment, you know, keeping the shoulders, head packed, core tight, keeping that good core activation. So I tell them, okay, now go ahead and squat down, keeping tight, kind of sitting into the hips a little bit, and then find your natural stopping point, okay? And I can't tell you how many times I've seen it. To this day, it still blows my mind, okay? I just love seeing it. That when this happens, it's like I can take a picture every time and I dissect it. It's like, man, that's 90 degrees. Okay, like I'm talking the hip joint and I'm talking at the knee joint approximately. I'm sure it's like, you know, 88, 85, 91, whatever. And it's like they get it from the very beginning, as long as they're able to keep, you know, that neutral alignment in their feet and hips, as long as they're able to keep their core tight, as long as they're able to keep that full body tension. If they let those things go, okay, if they let their feet rotate out, it's like, okay, yeah, they probably do go a little bit deeper, okay? So to get that 90 degrees, they don't have to. I would consider that kind of rotation out, okay, under high force conditions. I would consider that to be a subtle compensation pattern, okay? In my own training, that's what I would consider that. I'm not saying other people, you know, do it different. But so basically when we see everything kind of going to its optimal like alignment, okay, it's like, all right, that locks in the 90-degree position. When we see things kind of pull out of alignment, start to externally rotate, the hips and feet start to move out of position, maybe you lose a little bit of that core tightness, maybe you lose a little bit of that spinal rigidity, then it's like, okay, we see all kinds of stuff happen. Okay. So it's, and I always tell people, and I'll take pictures for them, my new clients, and I do this pretty much every time now. I'll have them go through squats, I'll have them go through chest presses, some rows, some lunges, and I'll show them the pictures and I'll say, hey, what joint angle does that look like? And they'll say 90. Okay. And I'll say, how much coaching did I have to tell you? Like, oh, stop here. No, that's 90. And they'll say like none. And I will say, okay, why do you think that is? Like that you happen to stop like right around 90 degrees. Like, isn't that kind of odd? You could have stopped at 70. You could have stopped at 110. How did it just randomly happen to go to 90? And I tell them like, look, I've seen this happen like hundreds of times. So how does this magically happen every time? It's like, unless there's something ingrained in our physiology, like this built-in 90-degree mechanism, because it's right biomechanically, neuromuscularly, structurally, like there's something our body gravitates to that doesn't even need a lot of coaching if we just give it the opportunity to kind of find it. So
Got it. Yeah. Interesting. So sometimes when I see people's feet slide out, there's a question in my mind of, okay, is that because their hip joint needs to externally rotate to align for hip flexion with their feet on the ground? Or is it because they have some, neuromuscular thing?
Right. No, I think
That's a hard question to answer because
it's a good question, because I think a lot of it is differences in the anthropometrics and their hip anatomy. So here's what I would say to that. I would
yeah.
say, hey, if they're picking something up off the ground, if they're doing a tire flip and they have to squat down and get it, have at it. If you want to rotate your hips, go for it. Go rotate as much as you feel like your body needs to.
Mm-hmm.
Okay. But in those kind of 90-degree parameters, here's what neutral is, and here's what's, kind of what I would consider optimal. But when you have to go deeper in that for special circumstances, that's when you let the anthropometrics and the individual differences in anatomy dictate what they need to do differently. And I don't have to stop that.
It's almost like, they're just different exercises. I mean, the squat that you're saying, it's just a different exercise than a deep squat, right? It's like,
exactly.
It's like doing like, let's say I was doing a neutral grip press in a kneeling position versus like a barbell press, right? They're both presses, but they're different exercises because they're trying to accomplish different things.
Exactly.
I wonder if we'll ever see Dr. Seedman use a limited amount of externally rotated squatting, just as the Olympic lifter used a little bit of the toed forward squatting.
Hey man, never say never, right?
I'll never. Well, look, I was playing around before the podcast, squatting the way that you suggest, because I was looking at the pictures where you documented it. And it was like, look, I mean, if I was going to train, like thinking about being in a sport and being in a position where I needed to do that, it is a better position, in my opinion, for like the knee to press to go forward. Or like, let's say you had a football player and their feet are pointed out. I mean, that's definitely not the best position for the knee to be in to drive force forward. Like, I definitely agree with that. But I just see it as different exercises for different reasons.
No. I mean, I think the way you're looking at it too is great, because you're looking at it from all these different perspectives and not just like in this little box, which a lot of people do. And I think that's what these I call them haters or lunatics. I like to call them deranged lunatics, because I have no issues with someone disagreeing with me. I think it's great. I think this disagreement, even with us, we have a little different views here, but we're having a cordial, civil conversation. We're hopefully doing something small in our own little way to advance the field as we do this. I'd like to think so. And as more people do these type of podcasts, if they can do it civilly. So as soon as these, different, people or coaches, when they have this like, oh, you're such an idiot, like what's wrong with you? You're such like how stupid is this? Like, you should send back your PhD. It's like, dude, like we're getting nowhere. Like we're not having anything to,
they're not trying to understand. There's a difference in trying to understand why somebody thinks differently from you versus trying to prove why you're right and they're wrong.
Exactly.
And nobody gets better from that ever. Like that doesn't help anybody. And it's definitely not the way to change somebody's opinion.
No, exactly. And even though like you may still squat differently than me, it's like the way you're analyzing it and we're looking at it pretty similarly. Like, okay, like look at all these different perspectives, look at all the different sciences, and then kind of don't just look at it from this small little kind of tunnel vision, which a lot of people do. Because like you said, it's like, hey, they learned it from their coach and their coaches did it this way, and the people that they watch do it this way. And, it's kind of like, we have to think differently sometimes. And just because something's never been done a certain way or isn't done as frequently like that or as consistently doesn't mean it's wrong. So it's just a different way of looking at it. I think, like you said too, it's kind of like in some ways it's just a different exercise. Like, like you want to call it like, okay, this is a 9, like, I don't even, maybe you could call it different. Don't even call it a squat. If somebody doesn't want to call it a squat because they think it's like, oh, it's not a squat. Okay, well, call it whatever you want. It's just, here's the method that I like to use. So
you should just call it the Seedman squat.
I think I'd get more haters going off on me calling something by my own name, man.
Hey, it's happened a lot, right? There's there's an Arnold press, right?
That's true, yeah.
That could
true.
be.
I don't think I think Arnold is in such elite category. I think he could have called 100 different things by his name. So who knows though? I'll have to play around with that and see how much flack I get.
Yeah, I mean, like if I were to think about it just fundamentally from like like think about a deadlift, right? There's a Romanian deadlift, there's a sumo deadlift, there's a single leg deadlift, there's a squat with the intention of going as deep as possible. There's a Seedman squat. There's whatever. Like
All the optimization of the acetabular-femoral rhythm squat.
Think about that. I have to think about that.
I know, right?
The 99. I mean, yeah. Yeah. I mean, it really is like it's just a different way of doing things for a different reason.
Yeah, that's true.
I know we have maybe 10 more minutes or maybe 5 more minutes before we can go. I really want to talk to you about, I believe you did your dissertation on eccentric isometrics.
Yep.
And I am not familiar with the reasoning behind that at all. So I would love if you could explain the eccentric isometrics for somebody like me who doesn't know much background about it.
Yeah. So essentially, it's a form of tempo or pause training. Okay, so I always tell people all eccentric isometrics are a form of pause training, but not all forms of pause training are eccentric isometrics. Okay. So basically, an eccentric isometric, we're doing a slow negative. Okay, and we're going down to, again, natural, what I would consider natural or semi-stretched position. Okay, around 90 degrees. And we're holding that position with co-contraction. We're essentially squeezing into it. We're not just pausing for the sake of pausing. We're not just kind of resisting the stretch. We're actually trying to squeeze into it. Like imagine somebody doing a chest press, and instead of just holding at 90 degrees, they're actually using their back to kind of row it into that 90-degree position.
While they create the tension with the pecs at the same time.
That's that co-contraction. And then we're just following that after a few second hold. With a forceful concentric. And again, that sounds like, okay, well, that's pretty much like pause training. Like you just go down, pause it, explode up. It's a little different because again, we're focusing on the 90-degree positions. We're focusing on the co-contraction, which is huge.
Yeah.
And then the key too is to understand that, okay, it's not just, doing a pause rep for the sake of putting more tension on the muscles, which is nice. It's a nice benefit. We get added muscle growth, added strength. We maybe hope to take some tension off the joints too. But one of the sole purposes of the eccentric isometric is to wake up those muscle spindles. This all goes back to that whole neuromuscular physiology stuff that I looked at. Muscle spindles, they give us all this feedback, and they are activated maximally when the muscles are stretched under tension. So when we have all that proprioception coming in during these eccentric isometrics, it starts to basically rewire our nervous system so that we can fine-tune movement. So if something is off, if one hip is a little bit more forward, or the knee is more forward, or maybe externally rotated this way, we can start to feel those things. We have better sense of feel. And so what my goal is with my clients and athletes is not to get them dependent on my coaching, but to get them dependent on their own body sense of feel, their own sense of feedback, their own kinesthetic awareness that the eccentric isometrics help to optimize. Then they can do that to fine tune their own movements. So instead of me having to tell them, it's like, no, pull your elbow this way, or tuck your shoulder down, or, pull your foot out. It's like, no, they can start to feel for all that. Eventually I can take a step back and they become the master of their own movement, and they can become their own coach. And that's ultimately for any sport or any activity or any skill, the better someone gets at being able to coach themselves, the more they master that skill, the better they get at it. So that's all it is.
Got it. Yeah. So the co-contraction is really one of the distinguishing, because unless somebody coaches you to do that, I don't think people are doing that like in a pause. Like if I was doing pause squats, right? It's like you're just kind of trying to not go down more when you're pausing, not squeeze every muscle around the joint to get maximal tension. And the reason you're doing that is for the spindle activation or whatever's happening there, in order to continue to build more body awareness. It's, kind of like an unconscious, like a muscle spindle is not really a conscious mechanism, at least. Well, maybe some of it is.
It's happening at the kind of deeper. Mm-hmm. It is. It's the subtle stuff like the oscillations and vibrations, the feedback we get during those times. It is not. It's not as conscious because it happens like within 30 to 50 milliseconds. But the ability to tune into kind of the bigger aspects of proprioception, we can then look at it consciously and start to kind of understand that. And that's why going slow, when I have people go slow, that's the whole eccentric isometric, go down slow, pause. They can feel all these things. It's like, oh, slow it down even more. If you don't feel it, slow down. If you're going down fast, I'm telling you, hey, correct your form. Like, how can I correct it? It happens so quick. By the time I felt anything, the movement's over, next rep. It's like, okay, you slow it down, tune into what's going on in your nervous system, use that feedback to make subtle adjustments, then we're getting somewhere. And then every rep we do is making you better. Every rep we do, we're perfecting the movement one step further, one step further. So it's a very cognitive process, a very cognitive training scenario where it's not just mindlessly going through reps. You can call it, maybe even like a higher level of like muscle mind connection with bodybuilders have tuned into for years. Yeah, no, that co-contraction thing is big, and it back to some of the science of it. It is maximized. There's research showing that co-contraction is optimized at 90 degrees. And we know at the bottom of an eccentric contraction, before the turnaround, before we go into concentric, we want maximal co-contraction to create reciprocal inhibition on the way up, so that we basically get releasing of the antagonist, so we can get maximal firing of the agonist. It's like a slingshot. So where does that occur? Again, the research shows it actually happens at 90. So again, this kind of all goes back to some of my theories with that.
Yeah, because it makes sense, right? Because if you were like at the end range position, you wouldn't be sort of like in an optimal length tension relationship range for like the agonist and antagonist.
Exactly. Well, no, that's exactly it. Because the whole, you're familiar with the passive insufficiency, active insufficiency. If you take your knee and pull your knee behind you and try to flex your hamstring, okay, you can't go past 90 degrees with your hamstring, because it's like you basically, there's so much tension in the hamstrings, they stop at 90. It's actually an interesting thing. Try it. Whoever's listening to this, you can try it afterwards. You basically stand up and you pull your leg back a little bit so it's slightly in extension, and then flex your leg and keep it properly aligned. And you literally, I have yet to see a scenario where somebody can go significantly past 90. That's called active insufficiency. So when the muscles are tight under tension, it's like you can't go farther even if you want to. If you went farther, okay, you're not firing the muscles any longer, which means you're not creating that co-contraction, which means you're losing some of that motor control too, because motor control, co-contraction, muscle stiffness, it all ties hand in hand.
It would be like this. If I grab my microphone and then you flex my wrist, you could way more easily take it out because I can't squeeze.
Exactly.
Yeah.
Same thing.
Do you have time for one more very short question?
Yes.
Okay. When you're working out, when you're training, are you thinking about like the position of the bones? Are you thinking about the muscle? Are you thinking about all of it? Like, what do you focus? And maybe that changes, but I'm curious.
I'm kind of, the farther someone gets, the more things they can, the more things I try to have them think about. So those are things that I do think about, okay, to a degree. And a few of my very advanced clients who have been with me for 7-8 years now, I have explained some of these theories of like joint centration, which, you're familiar with, basically where you got kind of equal tension and force dispersed across the joints. And we can even go further, within a joint itself, amongst the various joints involved. And we can even talk about centrated tension around a given muscle and around other muscles, like, a squat, for example. Like, ooh, man, I'm feeling too much tension on the inside portion of my knee. Okay, that's not centrated tension. Why is it happening? There's some valgus collapse, possibly. Am I feeling too much tension in my lower quads when I'm doing a squat? Maybe we don't have that centrated tension. Maybe we're not sitting back. Maybe we're not loading the glutes and hamstrings. So these are things that I try and get, people to tune into gradually, because you can't overload them and bombard them with too much information. It's what they can tune into and give them a little more. So those are all things that, I try to tune into, and the eccentric isometric protocols, it helps you, because it's like, okay, everything feels locked in, It's like, ooh, man, that felt like all of a sudden, like too much tension in this hip. It's like, okay, hold on. Oh, there it is. It feels better now. Like we make those adjustments. So yeah, I think it's like the most trying to be in tune with as much as possible when you're training. To me, that's the ultimate training experience.
That's like the point.
Yeah,
like
exactly.
for certain methods of training, right? It's like physical training is to get better at moving your physical body, which means bringing more of what you're doing into your conscious awareness.
Yeah, exactly. It's all about that awareness. Exactly.
And then, ideally, right, like you don't want somebody in their sport to be like, I need to get my lower trap to
No, exactly. I always
rotate
tell
my
people we correct it in the weight room so you don't have to think about it on the field.
ah
It transfers.
that's the quote of the episode, I think.
That's motor learning, right? How do we
Uh-huh.
change? It's like you start somewhere, you program your body in the most systematically controlled environment where we're going slow and able to kind of break things down and deconstruct it. Because when we start running, we start doing stuff in the field, we don't have that the ability to do that. Okay, things are happening too fast. We don't have that luxury. So we do it in here, we do it in the weight room, and then it starts trickling into our natural movement. And those things become our default strategy gradually over time. They start to change the way that we move, hopefully in a good way.
Hence, to bring it all back, why the squat form is that way, because on the field, you don't want people to have built the habit of doing that if they need to be moving in a particular way to protect their joints in a time when they're not able to consciously think about it.
Exactly. That was perfect. Tied it right in.
Awesome. Where do you suggest people who are listening to this or watching it follow you to stay up to date on what you're doing?
Yeah, you can go to my website, advancedhumanperformance.com, Instagram, Facebook. I also have a book on all this eccentric isometric stuff in 90. It's called Movement Redefined. I came out with it a little over a year ago, so that's on my website too. Check all that out. But a lot of this information and articles and stuff that I wrote, they can find more on that.
Awesome. I've really enjoyed this conversation. I think that people attack you about your thoughts, but I think that you're very open-minded to what you're doing and why. I don't think it's fair. I really don't think it's fair. And I think that you have good reasons for what you're doing. And I love that you think about it and come to your own conclusions. Because if everybody did that, how much more could we push this forward if we question what we're doing and put ourselves out there? I mean, it's not easy to put yourself out there for criticism when you're just saying what you think.
Right.
So
true.
I appreciate that you do that. And I appreciate you
Likewise.
coming on the show, man.
Thank you. My pleasure.
All right. Talk to you soon.
All right.